Welcome back to 5-Minute Chemistry. Today we are going to be talking about the elements. So this periodic table contains all the known elements, all 118 of them, and each element has its own unique identifier. All elements are uniquely named and they all have a unique symbol. So this symbol is either a single uppercase Latin letter or a single uppercase Latin letter combined with a single lowercase Latin letter. So all of the elements can be identified based on this one or two letter symbol they have. And if we take a quick look at their basic properties, you can see that most of the elements that have been discovered are actually metals. Those are the ones in red color here. There are a few metalloids in brown, which have some metallic characteristics, and we have a few non-metals, which are all the elements that you can see in green. The ones that are in black are artificial elements that have been produced in such a low quantity that their physical properties are not really known at this point. If we take a look at the alkali metals, so these are going to be the metals that you can find in the first column of the periodic table. So their symbols will be Li for lithium, Na for sodium, K for potassium, Rb for rubidium, Cs for cesium. From these, sodium and potassium, and nowadays lithium, which are the most important ones. The symbol for sodium is actually coming from German, so it's natrium. And potassium is also coming from German, it's kalium. And in a lot of European languages, these are the names of these elements. So if you see natrium and kalium somewhere, then you should know that these are sodium and potassium. So these are reactive metals. So in metallic elemental form, you will rarely meet them. They will react with water, react with oxygen in the air. So it's not easy to find them as elemental metals. Similarly, the alkaline earth metals are also quite reactive. They are in the second column of the periodic table. From these, I think magnesium and calcium are the ones that you probably meet the most, but strontium and barium are also kind of important for chemistry. One group of elements that most people probably know about are the noble gases, which have been discovered relatively late because they refuse to participate in chemistry. So helium and neon and argon, these are very much inert gases. Krypton, xenon, radon, you might be able to force them into some compounds, but it's not an easy job to do. If we take a look at the reactive nonmetals, so most of them we will find here on the right-hand side of the periodic table, except for hydrogen, which is a weirdo. So hydrogen is placed on top of the alkali metal elements, but it is a reactive nonmetal, so it has more in common with the elements on the right-hand side here. So hydrogen got its name because if you burn it, you will get water, and hydro is actually water, so hydrogen is the element that generates water. So carbon, nitrogen, phosphorus, oxygen, these are very important elements for living organisms. Sulfur, selenium also, and then fluorine, chlorine, bromine, and iodine, these are the very reactive elements from the nonmetals. While it is possible to store them in their elemental form, they are very reactive, especially under UV light. In elemental form are in diatomic molecules, similar to oxygen and nitrogen, just a bit more reactive than them. And then lastly, let's take a look at transition metals. So transition metals are all these metals in the middle of our periodic table. This section contains a lot of metals that are well known. These are less reactive than the alkali metals and the alkaline earth metals. So some of them you can even find in nature in their elemental forms like copper, silver, gold, mercury. I selected a few here for which the symbols are a little more difficult to memorize. So Fe comes from the Latin ferrum for iron. Copper is cuprum in Latin, so that's why it's Cu. Silver is argentum, so that's why it's Ag. Gold is aurum, that is why it's Au. If you know, aurea mediocritas, the golden middle road, that expression, or Marcus Aurelius from the ancient Romans. That's the same for gold, Au. And then we have mercury, which is Hg because it's hydrargyrum. So the H is coming from the same as for hydrogen. It's hydra. It's coming from water. And the G comes from argyrum, which is silver. So it is actually water silver. And it is very interesting that even in the Asian languages, so I only speak Korean, so I can only speak for that, mercury is su-un, and su means water and un means silver. So it seems like everyone, when they saw mercury, which is a liquid metal, shiny gray color, everyone was thinking this is kind of water silver. And then tungsten with the W comes from the German word Wolfram. This is one of the highest melting point metals. It was used as a filament in light bulbs before the LED and other more energy efficient light bulbs became popular. And one of the biggest corporations that was producing these tungsten filament lamps was called Tungsram, which is a portmanteau of tungsten and wolfram. So they just combined the English name of this element, tungsten, with the German name of this element, wolfram, to make the name of their company. Okay, so this is it for today, and I will see you tomorrow.